Independence of three events. In this module, you will learn about independence of three events. Let us first recall the definition of conditional probability. Let capital E and capital F be events of a sample space capital S of an experiment, then the conditional probability of an event capital E given that event capital F has occurred is given by probability of event capital E when capital F has already occurred equals probability of event capital E intersection event capital F by probability of event capital F. Example, a dice is rolled once. If the outcome is 1, 2, 3, 4, what is the probability that it is 4? Solution. Capital A is an event such that capital A equals 1, 2, 3 and 4. Probability of capital A is 4 by 6 equals 2 by 3. Capital B is an event such that capital B equals 4. Probability of capital B is 1 by 6. Probability of capital B given capital A has occurred is 1 by 4. Let us also recall the definition of multiplication rule of probability for two events. Let capital E and capital F be events of a sample space capital S of an experiment, then the multiplication rule of probability is given by probability of event capital E intersection capital F equals probability of event capital E into probability of event capital F given event capital E has already occurred. Probability of event capital E is not 0 equals probability of event capital F into probability of event capital E given that event capital F has already occurred. Probability of event capital F is not 0. Example, a box contains 10 black and 5 white balls. 2 balls are drawn at random from the box without replacement. Find the probability that both balls drawn are black. Solution. A box contains 10 black and 5 white balls. The total number of balls is 15. This implies that N of S, the sample space, is 15. First draw. First ball is drawn. Let capital A be an event of black ball in the first draw. The probability of black ball will be capital P of event capital A is 10 by 15 or 2 by 3. The ball is not replaced. Second draw. The ball is not replaced and then the second ball is drawn. Let capital B be the event of black ball in the second draw. The total number of balls now becomes 14. 9 black and 5 white balls. The probability of event B given that event capital A has already occurred is 9 by 14. Probability of both balls to be black is capital P of event capital A intersection capital B equals capital P of event capital A into capital P of event capital B given that event capital A has occurred is 2 by 3 into 9 by 14. This results in 3 by 7. Now let's find out about independence of two events. Let E and F be two events associated with the same random experiment. Then events E and F are said to be independent if probability of event E intersection F equals probability of event E into probability of event F. Example, a dice is tossed twice. The probability of getting 4, 5, 6 on the first toss and 1, 2, 3 and 4 on the second toss. Next, let us discuss dependence of two events. Let E and F be two events associated with the same random experiment. Then events E and F are said to be dependent if they are not independent. Probability of event E intersection F is not equal to probability of event E into probability of event F. Mutually exclusive events. Mutually exclusive means can't happen at the same time. What is the distinction between independent events and mutually exclusive events? Independent events deal with probability of events, whereas mutually exclusive events deal with subsets of the given sample space. Two independent events having non-zero probabilities of occurrence cannot be mutually exclusive. Conversely, two mutually exclusive events having non-zero probabilities of occurrence cannot be independent events. We will now talk about independence of three events. For three events A1, A2 and A3, there are two types of independence: pairwise independence and mutual independence. Pairwise independence. For three events A1, A2 and A3 with probability P of AI is greater than 0 for I equals 1, 2 and 3, P of A1 intersection A2 equals P of A1 into P of A2. P of A2 intersection A3 equals P of A2 into P of A3. P of A3 intersection A1 equals P of A3 into P of A1. A1, A2 and A3 are pairwise independent events. Mutual independence. For three events A1, A2 and A3 with probability P of AI is greater than 0 for I equals 1, 2 and 3. P of A1 intersection A2 equals P of A1 into P of A2. P of A2 intersection A3 equals P of A2 into P of A3. P of A3 intersection A1 equals capital P of capital A3 into capital P of capital A1. Capital P of capital A1 intersection capital A2 intersection capital A3 equals capital P of capital A1 into capital P of capital A2 into capital P of capital A3. Capital A1, capital A2 and capital A3 are mutually independent events. In this module, you have learnt about independence of three events.